Welcome to Logarithms in Geometric Progressions. You have actually seen this in operation when we did geometric progressions, but in that one we could have guessed and checked, but since we've learnt logs, we've actually done this before, but we'll do a couple of questions. So for this, especially when it's a GP, we're going to be using logarithms, because when you have an unknown, is the exponential or the power, then logarithms take place. The big reminder is the rule that we've learnt, a to the x equals y gives you x equals log a to the y. Now, remember the side that the x is on is where you're going to leave it, because most of these questions are going to be less than or greater than, and so it's important to know that the side that the x value is on when you're doing the change from a exponential to a logarithm. So we're just going to solve a couple first. So 2 to the n greater than 40,000 and 0.97 to the n minus 1 less than 0.05. And this is the rule that we're going to use. So notice that we're going to change. So base a to the x equals y, then the x equals log base a to the y. So keep that in mind. We have talked about that. So using the rule, if we've got 2 to the n is greater than 40,000, so that's base 2. So when you leave the n on that left-hand side and you take the log base 2 over, so it becomes log base 2 of 40,000. Now, because the log of any number greater than 1 is positive, such as log of 2, we leave the sign as it is. So I'll say that again. When you move because it's base 2 and the log of a number greater than 1 is positive, when you take it over, or when you move it to the other side and change it from an exponential to a log, it becomes n is greater than log base 2 of 40,000, the greater than, or the symbol stays the same. And so we get n is greater than 15.288. Now we're not coming up with an n in this case, so we'll just leave it as greater than 15.288. So for our next one, 0.97 to the n minus 1 is less than 0.05. So using the same rule, change your base. So you leave the n minus 1 because that's your indice or your exponent. You leave that on the left-hand side. But because now we're doing log of 0.97, which is less than 1, so the 0.97 is less than 1, that's a negative, which means because you're actually switching it around, this sign changes from less than to greater than. And so we get log of 0.97 to the 0.05. Putting that on your calculator, you get n minus 1 is greater than 98.352. So n is greater than, because you add the 1, greater than 99.352. So here's a example using geometric. So show that 8, 12, 18, 27 is a geometric sequence and find the number of terms that are less than 1,000. So firstly, show it's a geometric. So we just do it as a ratio. 12 over 8 equals to 18 over 12 is equal to 27 over 18, and they're all equal to 1.5. So it is a geometric sequence. Find the number of terms less than 1,000. So A was 8, R was 1.5, and we want the term to be less than 1,000. So putting it into our Tn formula, you get 8 lots of 1.5 to the n minus 1, and we want that to be less than 1,000. So 1.5 to the n minus 1 is less than 125 when you divide by 8. And then using the same operation, we change it to a log, and so n minus 1 is less than, because once again log of 1.5 is greater than 1, so the 1.5 is greater than 1, so it gets taken over as a positive, so it stays as is, and then you'll add the 1, so we get n is less than 11.9, so therefore 11 terms are less than 1,000. Thank you.